Good morning, grade 9. So today we're going to be covering resistance. So you guys have already gone through currents and voltage with Mr. Ginsburg. And today I want you to go to page 13 of your notes. And we're going to go through that investigation 3. And we're going to make sure that you guys understand exactly what resistance is. On this slide, you will see that there is a picture of a tollway or a toll gate. And you all know what a toll gate is. When you are traveling down to the coast, there are toll gates because you have to pay for the maintenance of the road. And we have used the tollway or the toll gate analogy to explain resistance. So the first picture shows a single resistor. Okay, and that is probably in a series circuit. So it slows down the traffic, but the traffic is still moving at a steady pace. Then the second picture, the picture in the middle, is showing three resistors placed in series. Now, as you can see, this is slowing down the traffic significantly, because remember, every single time those electrons are going through a resistor, their current slows down. Okay, so imagine the cars are the current or the electrical flow. Okay, and the toll gate is your resistor. In this analogy, we have no voltage, but what is voltage again? Grade 9s, voltage is muscle. Voltage is the physical quantity that is pushing the electrons through the connecting wire. If you look at the last picture, you have got three resistors placed in parallel. Now, in this situation, you can actually see that although we've still got the same number of resistors, they are placed in a horizontal plane, so more of the current can move through at a quicker pace. Okay, so if I had to ask what is better for current, I'm going to say the resistors in parallel. It's not going to slow down the current that much. But we're going to get into all of this a little bit more. It's just this toll gate analogy is a nice way of contextualizing everything. Then on the right hand side of the slide, I have got an actual formula that you guys are going to learn today. And that includes that resistance is equal to voltage divided by current. And you know what your SI units are. Voltage is V, current, which is I, is amperes, and resistance is in ohms. And that's named after George Ohm. He was a physicist that discovered resistance. Okay, or came up with a concept of resistance. So we're going to move on now to the next slide. And when we're just going to cover a little introduction to resistance, and then after that we're going to cover investigation 3. On page 13, you will see there's a little box there for the definition. The definition of resistance is a material's opposition to the flow of currents. So you guys are going to see that there's resistance in a light bulb, there's a resistance in a connecting wire, there's even resistance in the battery that you use. There's even resistance in the battery, but we'll go into that a little bit more in grade 10. Okay, so what I want you to do is please make sure that you highlight that definition. That definition is very important. And later on, we're going to do Ohm's law, and that is going to connect to this definition. You will see at the top of the page, there is a little paragraph. I want you guys to fill this in, okay? And make sure that you filled in all the little blank spaces so that you can understand, so that you can get a good introduction to this concept. All components in electrical circuits have resistance, even the connecting wires. Some components, like light bulbs, have high resistance. Putting more bulbs in series will increase the resistance and therefore decrease the current. So can you see that resistance and current have an inverse relationship? Voltmeters, which are always connected in parallel, guys, have very high resistance. Why do they have a high resistance? Because we are measuring the potential difference between 2 points. We don't want to take up too much of the current. We don't want to impact the current and take up too much of the current into the voltmeter, so it has a high resistance. It stops the current from flowing into the voltmeter. Ammeters connected in series, remember, always in series, have a low resistance. Why? Because we want to read the current. We want to get an accurate estimate of what is happening with the current. So please make sure you fill all of this in, and we'll carry on to the next slide where we're going to cover investigation 3. Grade 9s, I need you to please make sure that you are under investigation 3 and make sure that you read this very carefully, because you're going to use your FETS simulator to set this up. You're going to set up the series circuit, not parallel, series circuit, and there's a picture there of it with one cell, one bulb, and one voltmeter and an ammeter. Okay, so what I want you to do is make sure you set this up exactly. I think the next slide shows a picture of a circuit with one cell. You're going to take readings with the voltmeter and the ammeter. And what we want are 3 readings for the voltmeter and 3 readings for the ammeter. Because what you're doing here is you're only connecting, or you're only adding another cell. So you're first going to take the reading with one cell. So take a reading with the voltmeter and the ammeter. Then you're going to add another cell and you're going to take another reading with the voltmeter and the ammeter. And then finally, you're going to add a third cell in series and you're going to take that reading again. Okay, once you have filled in your little table, you are going to graph this. By now, you guys should be graph fundies. You should be golden. You should know how to do this back to front. The only thing that's going to be new for you here is the gradients, and I'm going to explain this to you properly, and you're going to know this back to front. I promise you. Do not stress. Do not freak out. Okay. When you are setting up your FETS simulation, I want you guys to make sure that each cell is only a 1.5 volt cell, and the light bulb that you are going to connect must be of 1 ohm resistance, 1 ohm resistance. Okay, and you can change it by clicking the light bulb. It gives you the option to change the resistance. The same thing with the battery. It gives you the option to change the voltage. Okay, excuse Zoe over here. She wanted to join into the video, so please excuse her, and we'll carry on to the next slide. So this is a snapshot or a screenshot of the FETS simulation. And you will see that I've got one cell of 1 volt. I have one light bulb of 1 ohm, and a current is I'm getting a current reading of 1.5. So you guys can put this in as your preliminary results with 1 cell battery. And then later on, you're going to be adding just another cell. Make sure that it shows the electrons. And not the conventional current, and make sure you have your labels and your values. And remember to add cells of only 1.5 volt with every step. Okay, I'm going to go on to the next slide. I'm going to explain gradient next. So, grade 9s, and you should know this from maths. A lot of you have done this in maths. When we are looking at a graph, you have 2 main axes. You have your y-axis and you have your x-axis. Remember, the y is your dependent variable and the x is your independent variable. What the gradient is the slope or the degree of steepness of your line of best fit. So it's looking at the rate of change. So these 2 variables, how are they connected, and by what value, by what mathematical value are they changing? So when we are looking at that slope, we are looking at the change in the y-axis, okay, versus or divided by a change in the x-axis. So what you would do here is you would choose 2 points on your y. So you choose y2 and y1, for example. So we've got there in the first picture. And you would look at the difference between the 2 of them. And you would divide that difference by the change in x2 and x1. So you choose 2 points on those on the x-axis. Okay. So if you had to look over here, let me get my highlights up here. You had to look over here. You have got point P over here and point R over here. So what I would want to do here is I would want to look and see here and point Q. And if this, I would want to know what's the difference between this is my x1, x2, and this is my x1. And then over here, this would be my y1 and my y2. And you're looking at the difference. So change in the y coordinates would be between Q and R, or between P and R, and change in the x coordinates would be between P and Q. Okay, and what you're going to do here is you're going to look at that. The rise is the y, it's called the y, and the run is the x. And that is going to equal your m, which is your gradient. Now, guys, I know it seems like complete, I'm not going to say Greek, because you guys are all Greek. I'm going to say French. It's just a lot to digest right now, but once you actually practice, it's quite simple. Okay, so at the bottom of page 13, you will see that there's a formula there for you to calculate the gradient, and it is explained exactly how I've said it there. Change in y, or difference in y, divided by difference in x is going to give me my slope or gradients. Okay. So grade 9s, this is the last slide for this video. I want you guys to fill in your results, your ammeter readings and your voltmeter readings. Don't forget to put your units. So for ammeter, it's either going to be in amps or milliamps, and for voltmeter, it's going to be V. Then I want you to draw your graph. And thirdly, I want you to calculate the gradients, or attempt to calculate the gradients. If you cannot do this, or if you're struggling or you're freaking out, just try, just write in pencil. The next video I'm going to cover all of this, but I want you to fill in your table, finish your graph, and finish your gradient calculations, and then you are going to complete the questions on page 15. Please do all of this before you watch the next video. Why am I saying that you need to do this instead of just watching the next video? How is this going to help you? How are you going to learn? So I'm not there to check and to see what you guys are doing. But if you're honest with yourselves, you will do this first, because this is how you're going to learn. If you just go straight to the next video and copy down the answers, you're not going to learn anything, and you're going to be wasting your time, and that's going to really impact when there's impact your results when there is an assessment. Okay, so grade 9s, I'm going to stop this video now, and then please complete those exercises, complete your graph, and check your answers in the next video.